Is there a relationship between coffee consumption and a student's performance on a statistics test? In a study by Stanford University's Department of Psychology, 3 groups, each consisting of 20 students, were given a 10-question statistics test to complete after 0, 2, or 4 cups of coffee. The study's variables of interest are coffee consumption, test scores out of 100, accuracy, the probability of getting a given question correct, hyperactivity, the number of problems a student attempted. We will determine if there exists a relationship between coffee consumption and a student's performance, defined by an increase or decrease in performance where there is an increase in caffeine consumption. We will be looking at the effect, if any, coffee consumption has on students' performance on a 10-question statistics test. Our data includes 3 groups of 20 students who drank either 0, 2, or 4 cups of coffee before taking a statistics test out of 100 points. The groups are coded in the data set by 1, 2, and 3 for 0, 2, and 4 cups of coffee. So we did a test for normality. Our data seems to follow more of a light-tailed normal distribution as shown to the right. And we also did a Shapiro-Wilks test with a p-value of 0.8098, which implies that our data is normal since 0.8098 is greater than 0.05. So this is an example of our data table. To the right is what it looks like on our website, and under the coffee column you can see that it's filled with 1s, 2s, and 3s, 1 meaning 0 cups, 2 meaning 2 cups, and 3 meaning 4 cups.
For our non-parametric testing method, we use Friedman's test, and this test was conducted on all 3 of our response variables, test scores, accuracy, and hyperactivity, to determine if there exists a relationship between these variables and coffee consumption. Our Friedman's test for test scores. To test for a difference in test scores, 20 groups are selected that include the test scores of students who drank either 0, 2, or 4 cups of coffee, and the test scores are ranked from 1 highest to 3 lowest. Our null hypothesis is that there is no difference in test scores between amount of coffee drank, and our alternative hypothesis is that at least one amount of coffee drank causes a difference in test scores. So for our test statistic, we got a T2 value of 3.5519, so we do not reject our null hypothesis, and we conclude that there is no difference in test scores between different amounts of coffee consumed. Similarly, for our Friedman's test for accuracy, we have the same 20 groups of students who drank either 0, 2, or 4 cups of coffee. And again, the probabilities are ranked from 1 highest to 3 lowest. Our null hypothesis is that there is no difference in accuracy. And our alternative is that at least one amount of coffee drank has a significant difference in accuracy. For our test statistic, we got a T2 value of 0.5876. So again, we do not reject our null, and we conclude that there is no difference in accuracy between coffee consumption levels. Our Friedman's test for hyperactivity. So again, we have the same 20 groups of students who drank either 0, 2, or 4 cups, and the number of questions answered out of 10 are ranked from 1 highest to 3 lowest. Our null hypothesis is that there is no difference in hyperactivity, and our alternative is that there is a difference in hyperactivity for at least one amount of coffee drank. Our T2 test statistic is 41.8350, so we do reject our null hypothesis, and we conclude that at least one amount of coffee consumed differs in hyperactivity levels. So using our formula for the cutoff, we got a value of 6.8063, and we use this to determine which amounts of coffee have a difference. So we found that 0 and 2 cups and 0 and 4 cups differ in levels of hyperactivity, but 2 and 4 cups do not. We also conducted a quick pages test for hyperactivity. So we suspected the ordering for most hyperactive to least is students who drank 4 cups, 2 cups, and then 0 cups. And our test concluded that there is sufficient evidence for this ordering, so we can use this to say that the more coffee a student drinks, the more hyperactive they were on this test.
The parametric alternative to the Friedman's test is a block design ANOVA. And for our data analysis, we're doing a 2-factor ANOVA where we are testing performance and the amount of coffee consumed. So our 2 factors are performance, which includes hyperactivity, accuracy, and test scores are being measured against our treatment, which is the amount of coffee that a student has had. And because we're doing a 2-factor ANOVA, there are 3 hypotheses that we're interested in testing. The first one is that there is no interaction between the factors, which is the most important one that we're interested in. We want to know if coffee affects performance. The second one is that the means of coffee consumptions are different. And the third one is the mean performance outcomes are different. And when we run our ANOVA, we will see that most importantly for our interaction, we have a p-value of 0.0042, which is less than our alpha, which is set at 0.05. Because it's less than alpha, we're going to reject the null hypothesis and conclude that coffee does affect a student's performance. For the other 2 variables that we're interested in as well, the means of coffee consumed, we also find that we're going to reject that null hypothesis and conclude that the means are actually different. And also for performance, we're going to reject the null hypothesis and conclude that performance does differ. Now, to support our ANOVA, because the results that we got is different from the Friedman's test, and so just to get a visual of what's going on with the data, we just constructed some graphs. And the first graph that we're going to look at is the comparison between scores and the treatment. So we can see by looking at it that those who consumed 2 cups of coffee doesn't really differ much from those who had none and those who had 4. But now, if you take a look at those who had none and those who had 4, you can see that between student 1 and student 11, there is a clear divide between both of them. Those who had 4 cups of coffee performed better than those who had no coffee. For the first 11 students, that's more than 50% of our sample, and that's why we got the results that we got. Now, for our second graph, we're looking at accuracy. And one thing that we have to note about ANOVAs is that they're very sensitive to outliers. And that also is probably why it gave us the results that it did. Because if you look at a graph like this, just by eyeballing it, you can kind of see that it looks like there's no real difference. But then if you look at, let's say, student 11 who had 2 cups of coffee, that data point is a clear outlier. Not very far, but it's a clear outlier. You can also say the same for student number 2 who had 4 cups of coffee. And so our ANOVA is going to tell us that there is a difference because of those outliers. And so that's where that result came from. And now thirdly, we're looking at hyperactivity. And from this graph, it's clearer than the other 2 that there is a difference in hyperactivity. You can see that those who had no coffee were attempting less questions compared to those who had more coffee. They were doing more questions, and those who had 2 were kind of in between the 2. But again, for no coffee and 4 cups of coffee, you can see that there's a clear difference. So using the results from our ANOVA table and the graphs that we've presented, it's fair to make the assumption that if a student is attempting more questions, their likelihood of getting a higher score out of 100 increases. Now, the accuracy doesn't seem to have a large variation, but we cannot say that based on looking at the graph, because our ANOVA has told us that there is actually a variation, and so we also have to take that into consideration. But just based on what we've done and based on what we have seen, we can see that scores and hyperactivity does actually vary when you look at the individual treatments. And because of all of this and the data that we've presented, it's okay for us to conclude that our 2 factors, performance and our treatment, the amount of coffee consumed, does share an interaction. And for our final conclusion, we will say that the amount of coffee consumed does affect or did affect a student's performance.
So after using both a non-parametric and parametric testing method, we can see that they provide 2 different results. So a parametric test provides significant evidence of an interaction between the amount of coffee consumed and a student's performance on a test, so their score, accuracy, and hyperactivity. However, our non-parametric method, Friedman's test, only showed evidence that coffee affects hyperactivity levels and not test scores or accuracy. So based on our QQ plot and our Shapiro-Wilks test, we can assume that our data follows a normal distribution, and this would mean that our parametric test provides a more accurate result. So to conclude, there is in fact an interaction between the amount of coffee consumed and all 3 of our performance variables based on our parametric test. And furthermore, we can use the results from our Pages test on ordering to infer that hyperactivity levels were highest for students who drank 4 cups, second highest for students who drank 2 cups, and lowest for students who drank no coffee. So it's fair to assume that an increase in coffee will increase a student's hyperactivity levels as well as their test scores and accuracy levels.